Hey there and welcome. Today, we're diving into the Chemical Detective's Casebook. We're going to equip you with a complete toolkit to identify substances you might not even be able to see using some really clever, simple tests. So let's get this investigation started. I mean, it sounds like a riddle, doesn't it? You've got this unknown thing. Maybe it's a perfectly clear liquid. Maybe it's a gas that's totally invisible. How in the world do you figure out what it is? Well, that's the big mystery we're going to solve today using some classic chemical investigation techniques. I want you to think of these tests as your detective tools. Each one is designed to give you a very specific clue. It could be a sound, a change in color, or even a new substance that just appears out of thin air. Your job is to gather all that evidence and correctly identify the chemical culprit. Okay, so our first case involves the trickiest suspects of all, invisible gases. They're literally all around us, but figuring out which is which, yeah, that takes some pretty clever interrogation. Let's look at the lineup. All right, suspect number 1, hydrogen. The test is so simple, but wow, it's dramatic. You take a lit splint, you put it near the hydrogen, and you get this unmistakable, squeaky pop. That sound you're hearing is actually a tiny, super fast explosion. It's the signature of hydrogen reacting with oxygen, and it's a sound you just can't mistake. Next up, we have oxygen. The gas that fire literally needs to breathe. This time, you're not using a full flame, just a glowing splint. If there's oxygen in that test tube, that glowing ember will instantly burst right back into a flame. It relights. It's such a cool visual way to see just how much oxygen fuels a fire. The test for carbon dioxide. This one is a classic. You might have even done it in school. We just bubble the mystery gas through lime water. And if that gas is CO2, the lime water, which is normally clear, will instantly turn all cloudy and milky. It's like getting a perfect fingerprint at a crime scene. You found your culprit. Now, chlorine is a really powerful bleaching agent, and that's the exact property we use to nail it down. You take a piece of damp litmus paper, which has a nice distinct color, and you pop it into the gas. If it's chlorine, puff! The paper gets bleached completely white. The color literally just vanishes. And rounding out our gas lineup, we have ammonia. Ammonia is what we call an alkaline gas, which is basically the chemical opposite of an acid. So to test for it, we use damp, red litmus paper. If you've got ammonia, that red paper will turn a really distinct blue. Case closed. So let's do a quick review of our invisible suspects. For every gas, there's a unique test and a unique piece of evidence to look for. A pop sound, a relit splint, milky water, bleached paper, or a color change from red to blue. Pretty neat, right? Okay, on to a new case. We've got a mysterious clear liquid. Is it water? To find out, we can use these special chemicals called anhydrous, which is just a fancy way of saying all the water has been removed from them. So if we add our liquid to some white anhydrous copper 2 sulfate, it'll turn blue. Or if we touch it with some blue anhydrous cobalt 2 chloride paper, it'll turn pink. Two totally different color changes, but they both point to one clear conclusion. H2O is definitely on the scene. But hold on, is it pure water? Those chemical tests can tell you water's there for sure, but they can't tell you if there's anything else mixed in. For that, we need a physical test. We check its boiling point. If that liquid boils at precisely 100 degrees Celsius, not 99, not 101, but exactly 100, then you can be absolutely certain it's pure water. That single number is the gold standard for purity. All right, get ready for the really fun part, maybe my favorite part of the toolkit, flame tests. We're about to see how different metal ions give themselves away with these spectacular bursts of brilliant, unique color when you heat them in a flame. It's like chemical fireworks. So how's it done? Well, it's actually pretty simple. You take a wire, you clean it really well, you dip it in your unknown substance, and then you stick it in a flame. The most important thing here is to make sure your wire is super clean and the flame is clear. That way, you know any color you see is a direct clue from your chemical suspect, not just some random contamination. And here we go. If you see this incredibly vivid crimson red color, boom, you found lithium. It's just this beautiful, unmistakable clue that screams you've got the Li+ ion. This intense yellow-orange flame. This is the calling card of sodium. If you've ever looked at an old-school streetlight, you'll recognize this color in a heartbeat. It's a really strong, dominant color, and it leaves absolutely no doubt you're dealing with sodium. Now, this one's a little more subtle, but it's just as beautiful. It's this delicate lilac, almost a pale violet flame. This is the telltale sign for potassium. Yeah, it's not as in-your-face as sodium, but its unique color is just as conclusive. Okay, check this out. An orange-red flame, almost like the color of a fiery brick. This is the signature of calcium ions. If you think about fireworks, calcium salts are often the secret ingredient used to create those beautiful orange colors. And last but not least, this absolutely stunning blue-green flame. This is the unmistakable clue that you are looking at copper-2 ions. Again, it's a color you often see in pyrotechnics, and in the lab, it's just fantastic evidence. Okay, let's lock in that evidence, shall we? Red for lithium, yellow for sodium, lilac for potassium, orange-red for calcium, and that beautiful blue-green for copper. Each one of these metal ions has its own unique Technicolor fingerprint. For our final case file, we're going on a hunt for anions. Those are the negatively charged ions. Now, these suspects are often hiding in plain sight, completely dissolved in a clear solution. So our technique is to force them out of hiding by making them form a solid. And that solid has a special name, a precipitate. So the trick here is to add another chemical that we know reacts specifically with our hidden anion. That reaction forces the anion to clump together and form a solid that just appears right before your eyes. And that solid, that's the evidence we need to crack the case. So each anion gives us a different clue. For carbonate ions, you add a little acid and you get fizzing, that's evidence of carbon dioxide gas. For sulfates, adding some barium chloride solution reveals this thick white solid. And for the halide ions, chloride, bromide, and iodide, adding silver nitrate is the key. You get distinct colors, a pure white precipitate for chloride, a cream-colored one for bromide, and a pale yellow one for iodide. So there you have it, your basic chemical detectives toolkit all laid out. We've gone over tests for gases that use sounds and visual changes. We figured out how to identify water and even check its purity. We've unmasked cations with that dazzling display of colorful flames, and we've forced hidden anions to reveal themselves as solid precipitate. And that's a wrap on our investigation for today. You know, these lab tests might seem pretty simple, but they're really the foundation of how we analyze everything. It kind of leaves you with a final thought, doesn't it? What other invisible clues is chemistry helping us uncover in the world all around us every single day?